Hello everyone. Welcome to this channel. Today's lesson is related to photoelectric effect. By definition, photoelectric effect is ejection of electrons from metal surface when light of sufficient frequency falls on it. What this definition means? It means that any light cannot lead to photoelectric effect, so it should possess sufficient frequency to be able to remove electrons from metal surface. Ejected electrons are called photoelectrons. The current produced is called the photoelectric current, and the minimum light frequency which can lead to ejection of electrons is called the threshold frequency. Setup of this experiment is shown below. You see that we have a battery which is not in a circuit which is not closed, but by emitting light on this part of cathode part of this wire, which is indicated by a negative sign, you see that the electron will be able to jump from negative to positive, or from cathode to negative, to this anode, which is positive. And the ammeter, in absence of light, ammeter will mark zero current, but in the case current is being emitted on this cathode, ammeter will show that we have current which is flowing through this current. So as you see, it is clear that we have resistance there. The purpose of this resistance is for protection of ammeter. Then observation, which is from this experiment, what to observe there, no photoelectrons are emitted if light frequency is less than threshold frequency. Number 2, kinetic energy of photoelectrons depend on frequency, not intensity. Number of photoelectrons emitted depend on intensity of light. As we know, intensity of light is related to number of photons which are emitted in this light. It means that as long as we increase the number of photons, also number of photoelectrons ejected will be increased, because we know that each photon will interact with one electron. That's why number of photons will affect the number of ejected electrons. Emission is also instantaneous. Instantaneous means no time lag. No time lag between emitting light and emission of electrons. Instant relation in photoelectric effect. HF is equal to C plus KE, where HF stands for the energy of instant radiation, and Phi also stands for work function, then plus kinetic energy of ejected electrons. In this experiment, you see that part of light emitted will be absorbed by some electrons, and the remaining energy is the one which will take electrons from metal surface, or electrons will move with, which is transformed into kinetic energy of ejected electrons. H is Planck constant. Otherwise, Planck constant is equal to 6.63 times 10 power minus 34 joule a second. and F stands for the frequency of incident light. And T is work function. Work function has minimum energy needed to remove electron from metal surface. And K, mx, is maximum kinetic energy of photoelectrons. Let us continue and see another point which is called stopping potential. Stopping potential is a potential which can be applied on the circuit that we have seen above, so that it can stop moving electrons. To stop moving electrons, we apply a reverse potential, Vs, which is known as stopping potential, where E times Vs is equal to kinetic energy. Of course, if we take this electron as a charge times stopping potential, it will produce energy which should be equal to kinetic energy, because we want energy to minimize, or energy which can balance this kinetic energy of moving electrons such that they may stop. Then from this equation we see that Vs will be equal to kinetic energy then over electrons. Application of photoelectric effect. We have solar cells. It is applied in solar cells. Also, photoelectric effect is applied in photoelectric sensors, television and camera tubes, and also in automatic lighting. So let's start from solar cell. In solar cells, they are made such that once light falls on it, electron can be ejected, and once they are ejected, they produce electricity. And also photoelectric sensors. Photoelectric sensors, they work in such way, once light is available, they can perform a certain work. And also in television and camera tubes, photoelectric effect is used in the monitors. Once light finds a certain screen, electron can jump, then we can see some image. In automatic lighting, also photoelectric effect is used there. Okay, this is the end of the lesson of today. So if you enjoy or if you love this video, make subscribe and like and share to others, so that any other video, you will be the one who will receive the notification in first attempt. Thank you so much.